Section 9.4, Simplifying Rational Expressions. The simplest form of a rational expression is when its numerator and denominator are polynomials that have no common divisors. When simplifying rational expressions, we have to remember always to factor the numerator and denominator. That will help us simplify that rational expression. We also want to state restrictions of the polynomial. We need to find the values that would make the function undefined. Let's take a look at our first example. Here I want to simplify each rational expression. I also want to state any restrictions. Here I have 18m cubed n squared over 6m squared n cubed. I want to state the restrictions. Here m cannot equal 0 and n cannot equal 0. If 0 would be substituted in for m or n, or both at the same time, my function would be undefined. Therefore, I have to state the restrictions. M and n cannot equal 0. Now I can simplify. 18 divided by 6 is 3. M cubed over m squared is, we rate the m on the numerator. 3 minus 2 gives me m to the first. Again, n squared over n cubed. 2 minus 3 is a negative 1 exponent. But with the negative 1 exponent, I know that drops to the denominator. 3m over n. By simplifying, I eliminated the m in my denominator from the original problem. That does not mean I don't set that as a restriction. I always set my restrictions from my original function. So here, m and n still can't equal 0. On my next problem, I've already stated my restrictions. Again, m and n are not allowed to be 0. I state that from my original function. And here what I'm going to do is factor a common factor out of my numerator. That would be a 4m squared. And when I factor a 4m squared out, that leaves me with 3 plus 2n over 28 m to the 5th n cubed. Now I'm just going to simplify with the 4m squared and 28m to the 5th n cubed. When I do that, I'm going to have 4 over 7 is 1/7, or 7 in the denominator. My m rewrites in the numerator, but that gives me 2 minus 5, which is a negative 3. 3 plus 2n. And my n cubed stays in the denominator. But since this is a negative exponent, that variable must drop to the denominator. So that gives me, as my final answer, 3 plus 2n over 7 m cubed n cubed. Here, I want to simplify my expression. Again, state the restrictions. To state the restrictions, I need to factor first. So on the top, I'm going to rewrite this by using the commutative property, which is x plus 5. And I'll factor the denominator into the product of two binomials. Here, 2x and x. And that will be 1 and 5. And that will be minus plus. And I can verify that. 2 times x is 2x squared. Positive 10x minus 1x is positive 9x. And finally, the last is a negative 5. Now I can find my restrictions. That would be 2x minus 1 equals 0. And when I solve, x is going to equal 1/2. So x cannot equal 1/2. And x plus 5 equals 0. X equals a negative 5. So x can't equal a negative 5. In each case, if I let x equal negative 5, that would make this binomial 0. 0 times that would make my function undefined. Similarly, if I do 2 times 1/2, that would give me 1 minus 1, which is 0. Then the product of that would give me 0 in the denominator, again undefined. Now what I want to do is simplify, and my x plus 5 expressions will cancel in the numerator and denominator, leaving me 1 over 2x minus 1. But I still maintain that x cannot equal a negative 5 as a restriction. Again, on my next example, I want to factor the numerator and denominator. So my numerator, that's going to give me 7z and z. And I'll break up my 6 into 2 and 3, and that will be plus, plus. And my denominator, z and z. And that will be a plus 3 and a minus 1. My restrictions are going to be z plus 3. I set to 0, and that gives me z equal to a negative 3. So that quantity will become 0 when z is a negative 3, so z can't equal a negative 3. And the next one is z minus 1 equals 0, and z equals 1 when I solve that, so z can't equal 1. When z is 1, that quantity will become 0, and that makes the function undefined. Now what I want to do is to simplify, crossing those two binomials out because they simplify. That gives me 7z plus 2 over z minus 1. Again, I want to simplify each rational expression and state the restrictions. To do that on the first example, I need to factor the denominator. That gives me 5x over. I'll factor out a common factor, which would be 5x. That will leave me 3x minus 2. I set each quantity to 0 to determine my restriction. 5x equals 0, or x equals 0 when I solve for that. Therefore, x is not allowed to be 0. If it is, 0 times 5 is 0. 0 times the quantity gives me 0 on the denominator, which would make the function undefined. Next, 3x minus 2 equals 0. And when I solve, that's going to give me x equal to 2/3. 2/3 times 3 would give me 2. 2 minus 2 is 0. 0 times this quantity would give me 0 in the denominator, which would make my function undefined. Therefore, x cannot equal 2/3. Now I simplify 5x over 5x. That cancels. Leave me a 1 in the numerator. 1 over 3x minus 2. Again, I want to factor, but since my bottom is in the form of g squared g and then a number, I'm going to use my commutative property and rearrange my numerator. That will give me 3g squared plus 16g plus 16 over g squared minus 3g minus 28. Now I can factor the numerator and denominator. That's going to give me 3g and g, and that will be 4 and 4. 4 times 3 is 12, plus 4 gives me 16, and that will be positive, positive. On my denominator, g and g, that will be minus 7 and plus 4. Now I can set my restrictions. Again, I want to set each quantity in my denominator equal to 0. G minus 7 equals 0. Therefore, g equals 7 would make my denominator 0. Therefore, g is not allowed to be 7. And g plus 4 equals 0. G equals a negative 4 would make my denominator 0. Therefore, g cannot equal a negative 4. Now I can just simplify. And when I do, the g plus 4's cancel out. And that's going to give me 3g plus 4 over g minus 7. Again, I want to state restrictions and then simplify the expression. Here I can determine that a cannot equal 0. That would be my only restriction. If a is 0, my denominator would be 0, and my function would be undefined. Now I can factor a common factor out of my numerator, which would be 8a, and that would leave me with 2a minus 1 over 32a cubed. Now I'm going to simplify. 8 over 32 leaves me a 4 in the denominator. A over a cubed. That would be a to the negative 2 in the numerator, which would give me a squared in the denominator. And what's left in the numerator is just going to be 2a minus 1. Again, I want to factor the numerator and denominator. That's going to give me difference of squares in the numerator. That would be x plus y times x minus y. And factoring the denominator, I get x and x. And that would be plus 3y plus y. Now I can determine my restrictions. That would be setting each quantity in the denominator equal to 0. X plus 3y equals 0. X equals a negative 3y. So x can't equal a negative 3y. And x plus y equals 0. X can't equal a negative y. And we could do the same thing by solving for y. And here, y couldn't equal a negative 1/3 x, and y can't equal a negative x. Now I can simplify. My x plus y's are going to cancel, and that's going to leave me with x minus y over x plus 3y.